For our second example, we have two terms that are subtracted from each other. Each term is made up of only factors. There's multiplication within each term. There's factors within this term and factors within this term. In order to find the sum or difference, in this case, between these two terms, I need to consider what would be the common denominator. Well, when we look at the least common multiple for this denominator, I've got a 16 here and a 5 here. They don't have any common factors, so I'm stuck with using their product, which is 80. Then I have to decide what other factors I need. Well, in the first term I have a t squared, and the second term I have a t, so t squared is going to be the least common multiple between the two. I also have an a cubed over in the second term, and I'm going to have to account for that. So by using a t squared and an a cubed, I have created what would be the common denominator. Now we go back to each term and decide what factors we still need. Well, as far as the 80 goes, in the first term I'm going to need to multiply top and bottom by a 5. I have the t squared there, but I'm going to need an a cubed. So I need to multiply top and bottom by a cubed. It's really important that you're writing this for both the top and bottom. As we get into further sections where we're solving, it can get quite confusing. So don't get lazy thinking you can only write one of these, because it's very important that you're writing factors on top and bottom. We're not changing this term, we're just changing the way it looks. And it's very important that you're changing this one term by that you're not changing this term because you're multiplying by a value of 1. Alright, so what is the value on this term? The numerator now becomes 15. A cubed and a squared makes an a to the 5th. Minus, what do we need to match this denominator here? Well, I'm going to need to multiply top and bottom by a 16. And I've got an a cubed and a t. Well, I got the a cubed alright, but I'm going to need one more t. So I'm going to multiply top and bottom by another t. So now I need to do 2 times 16, which is 32, and then I'll have an x and a t. At this point, if you look at this final result, is there anything that I can factor out of the numerator? If I could factor out something out of the numerator, it could possibly cancel with factors in the denominator. But as it stands right now, and there are no common factors, I can't simplify into these terms up here. They are two separate terms, and really there are parentheses locking those two terms in together. If I was so lucky that I could factor something out, that I'd have a factor times this, then possibly I would be able to cancel that factor with this, assuming that they would be like factors. That's example 2. Find the next one. I thought I had another example in here. Here's example 3. What happens with example 3 is that now we don't have terms that are made up of only factors. We actually have polynomials for numerators and denominators. This gets a little bit more tricky because you have to be aware of what's terms and what's factors. To start with, when you look at these large denominators of multiple terms, it's very hard to imagine what their factors are. So what we're going to do is actually factor these denominators. If you factor the denominators, you end up with factoring a 6 out, and you get 6 times an x minus 3. Over here, you need to factor, we first see we can factor a 2 out of all of these, making a much smaller trinomial. And now this trinomial we can factor. And I'll give you a dirty hint here. You know you got to split this up as 2x and x. And considering the fact that the book made the problem and they don't want to be too hard on you, chances are you got a pretty good likelihood that this x minus 3 just might show up over here. So it's just a good place to start your guessing. I'm probably going to be looking at an x minus 3 and a 1 here, and to make a negative 7 I'd need a negative 1 there. Make sure you double check this product that you get back to the 3. Let's not trip on the old factoring rules. So at this point, this is what I have. Now we have to decide what is the least common multiple. Well, as we look at this, I have a factor on the bottom over on the first term as a 6. I have a factor here of 2. So I'm going to need to multiply top and bottom here by a 3. I have an x minus 3 in both, so I'm good there. This term over here has an extra factor of 2x minus 1. So I'm going to need to multiply by a 2x minus 1 on top and bottom here. A couple of safety tips now you have to really keep an eye on is the fact that now in our very next step we will put these all together as one denominator. Well, I guess I didn't do that quite yet, but what we're going to do is go plus a negative sign. So we have this negative 3. This negative 3 is going to distribute into that term. Into this factor. This negative 3 is a factor distributing into this factor. The 5 will distribute here. So, having a common denominator of 6, x minus 3, 2x minus 1, what is in the numerators? Well, we ended up with 10x minus 5, and I said plus a negative, which is really smart, so I get to make this a plus sign, and I end up with a negative 3x plus 3. What's nice about making this positive is I don't have to worry about losing this negative sign, which is a classic mistake that's even made in calculus. Now I'm ready to actually add my numerators together. Looking at our result, I have 10x minus 5 plus a negative 3x plus 3. What does this give me? Well, the 10x minus the 3x will be a 7x. Negative 5 with a 3 is a minus 2. Now, notice that I'm keeping the denominator factored, and you need to keep rewriting it because otherwise it's guaranteed that you'll forget later on. The next step we always consider is, can the top factor? Would the numerator possibly factor into something that would cancel with the denominator? That's why we want to leave these factored, because I can tell you every once in a while you'll get so lucky that it does happen. Remember that only factors may be reduced when they're both in the numerator and denominator. I can't consider anything about the 6 that's a factor and the 2 that it's not. This numerator is locked up. These are two terms that together could be wrapped up and considered all one factor. If this factor, 7x minus 2, was down here, I would be able to cancel the whole thing, leaving a 1 on top. But because I don't have a complete identical factor to 7x minus 2 down here, this is my final solution.